Hey everyone, thanks
Okay.
for joining us. I'm Arvin from Arc 3D, and this is Michael Rubloff. Arc is a alliance for radiance computing, and it's what it is an association that's focused on radiance fields and specifically the implementation of radiance fields. And so what we're what we're focused on is highlighting individuals and organizations that are using radiance fields. And so we're here today to recap Siggraph that happened last week. And so without further ado, I'm going to introduce Michael here, he'll intro himself, and then we'll go into what exciting things we experienced last week at Siggraph. So without further ado, Michael Rubloff.
Yeah. Thanks, Arvin, for the introduction. I am Michael. I am the managing editor of a website called radiancefields.com, and also, a part of ARC, as Arvin was just mentioning. There's a lot of interest right now out in the world about very lifelike 3D reconstruction through different radiance field representations, such as Gaussian splatting. And so, with Siggraph occurring last week, there was a lot of interest across a variety of industries and people who are either building with the technology, experimenting with it, or deploying some kind of product as well. So yeah, it was a super busy and exciting week, and yeah, I guess I'm excited to chat through a couple of the things that I saw there.
So let's start off. What's the most exciting thing that you saw last week in regards to radiance fields?
Yeah, so there was like so many demos and announcements and things that people could go experience there. I think where I'd like to start with it is stemming from the actual keynote address from Siggraph, where they had three of the executives from NVIDIA. They had Aaron Lafont, who I believe is the VP of graphics research at NVIDIA, as well as Sonia Fiedler, who I believe is the VP of AI research, and then Mingyu Liu, who I believe is another VP of research there as well. And so NVIDIA announced something called the NuRec library, and this essentially is a Gaussian splatting library that can be used in both Omniverse and Isaac Sim. So really targeting, the robotics and simulation-based industries, where it sounds like Gaussian splatting is starting to really make a impact on these two industries specifically, and is now kind of allowing and enabling some of these other developers throughout the world to leverage, NVIDIA's core offerings in both a simulation-based task, as well as putting it just directly into Omniverse and Isaac Sim. So that was very exciting for me to see this like direct acknowledgement from a large player in the space. One of the quotes that I really liked from the talk was from Aaron Lafont, which was a pretty basic one in its content, but I think has a lot of implications for the future. And Aaron basically said that we've firmly entered an age where just using normal 2D images or video, we have the power to reconstruct really lifelike 3D. And I think that this is one of the basic tenets of Gaussian splatting and like inverse rendering. But I think that having this direct acknowledgement saying this really is here now, this capability to reconstruct the world around us and then do more downstream tasks as a result from that, I think is just like a really exciting proclamation to just like firmly make it at this point.
Definitely. And I think that just from the outside, Siggraph seemed like there was a lot of, there's always a lot of things, but Radiance Field seemed like it was integrated deeply in a lot of the different announcements and things that were going on.
Yeah, exactly. So it was really awesome to just like see all these different like splatting examples on as part of the keynote. Some of the other things too that I thought was really interesting from more of a product side was there was quite a few demos from the Myris team. So they did a talk on the first Sunday of Siggraph where it was part of the Open VDB session. And so basically, Myris is taking a look at building the actual infrastructure of delivering, 3D or dynamic 3D content to, everyday devices. And so I think that, seeing their work, I think will be very critical to the actual advancement and proliferation of this technology out to the world, because we are we have pretty high expectations when it comes to interacting with content now, especially in a digital capacity, that for this technology to really spread and be utilized in both like a professional and personal capacity, I think that it's important that it meets our general expectation of 2D as a general baseline. And so Mirus is essentially building that infrastructure to be able to stream it out to devices. So, as we all know, like Netflix really pioneered this ability to stream just 2D video and kind of like change the way that we are as consumers, like ingesting, either media of some kind. And, obviously there was a lot of, followers from there, where Mirus is essentially saying, let's now extend that streaming capability to the 3D world too. And so I got to see quite a few demos from their team, kind of serving content in a, streamable, but still Gaussian splatting based environment, which is really cool to see. And this was both on like, static captures and dynamic ones. So the static ones could be like, delivering, say, like a chair on like an e-commerce page for like something like a Crate and Barrel or something like this. But being able to rapidly load in the content and stream it on the fly was really impressive to see. And was also quite cool too is that Mirus is built in part using a NVIDIA platform called FVDB. And so we started to see some of like the teasers of, what FVDB can do across the last year. And actually at Siggraph 2024, someone had asked, the NVIDIA CEO and co-founder Jensen Huang about what he was most excited about, and his answer was FVDB. And so it was cool to now see what is being done in there. So there was also quite a bit more peeled back about what FVDB's capabilities are, and that it looks like it's still continuing to plan to be open sourced. It sounds like in sometime in October, it will be out on its own, GitHub repo for people or for developers at large to really build on top of. Which basically this is a deep learning framework that's essentially unifying all of these different portions of the different repositories that are coming out of like different academic worlds, but essentially making it a bit more commercialized and ready to be deployed with only using PyTorch as a dependency.
And seeing that, while it doesn't generate the best like highlight videos, that's to me the most exciting stuff, because it's really like radiance fields are maturing to a point where they're becoming commercialized, where distribution's getting handled. And these are the things that I think are really exciting to see at conferences like Siggraph, because it's it's showing the progress of where this is going.
Yeah, exactly. And so there's definitely like a lot of examples of that too. One of the sessions that I went to, there was a paper that still hasn't got like a ton of attention yet called Radiance Surfaces, which I thought was really incredible. It's basically just a couple of lines of additional code into like InstantNGP, NVIDIA's nerf method. And it is radically speeding up the rendering rates of nerfs, or of InstantNGP, where some of the examples they showed had it pushing nearly 400 frames a second, which is pretty crazy. It's really fast. But in addition to that, it's also doing instant surface reconstruction as well. So it's got like these really nice benefits. There's actually an open PR in InstantNGP, and the author of Radiance Surfaces is having a conversation with Thomas Muller. And so it sounds like it's getting very close to actually making its way to InstantNGP as a finalized product, or a finalized offering rather. And I'm excited to see that be out in the world.
That's awesome. Yeah, definitely gonna look into the radiant surfaces. That sounds exciting.
Yeah. And some of the other places that we got to see these radiance fields out at Siggraph was in real time live. There were a couple demos that were really cool. The first one was one called Painting with Gaussian Splatting Paintbrush, or Painting with Gaussian Splatting Brushes, I think, or maybe it's the other way around. But anyways, essentially it is allowing people to essentially, use Gaussian splatting as like another creative medium for doing either rapid like prototyping of, say, a given location, or just kind of like playing around and having fun with a space. So really letting you like edit and essentially paint with the technology. So the demo they showed was essentially, a fire pit or a campsite area where they are going ahead and they had like a fire brush where they're able to like drop flames into like the campsite, as well as just like shows a more tangible and practical application of the technology where they're essentially inserting like rock walls into the background to kind of show, if you were like a landscaping company, for instance, here's a way that you could show your clients, for instance, what your work might look like for them, and give your clients a more easy way to visualize and get buy-in for your work. So I thought that one was really cool to see. There was another one a little bit after it that actually ended up winning Best in Show for Real Time Live from a company called Infinite Studio, otherwise known as 4DV. And basically, this is a dynamic Gaussian splatting implementation that is really incredible in terms of the fidelity that and temporal consistency that they're able to achieve. The CEO gave quite a few demos of various scenes, and one of them he actually like lowers the splat opacity to let you actually see the individual Gaussians kind of like moving through like space and time, so you get a like better sense as to like this is an actual like sparse 3D volume as opposed to just being like this just looks like 2D to me. So that was really amazing, and I think it like resonated with the audience a lot because it won best in show, which was voted on by the audience. And they showed examples of it running in Blender in both Eevee and Cycles, and then they also brought it into Unreal Engine as well for another demo there too. They actually had at one point like all of the different instances running at the same time, and it didn't actually cause his laptop to like slow down up until they put it finally into Unreal Engine. But that was, I think, solely because they had so many different 3D applications running the same demo at the same time, or a demo at the same time. And when he closed out the other programs, the Unreal Engine functioned completely perfectly. So it's cool to see this technology run on existing hardware right now, and it's not something that feels a bit like unachievable. And even in their like Blender version too, they were showing a fully ray traced version of Gaussian splatting as well. So it's like the technology is moving just so quickly. And I guess when I say dynamic Gaussian splatting, I should like qualify it by saying there's static Gaussian splatting, where you could think of that as like a 3D photo, like a frozen moment in time. And then the dynamic one essentially extends it into time as well. So kind of like a 3D video where you can really just experience a full video, but you can walk around and explore it.
Which, it just seems like the logical next step. We had 2D video, and then we had, 3D stereoscopic video, and now 6-stop full, fidelity video. There's been volumetric video, but, like VolCap and stuff, but I don't think anything comes close to this fidelity, what we're seeing. And again, the temporal consistency is really like the key there, because it like, there's no artifacts. It literally looks like it's, what you're expecting to see.
Yeah, exactly. It just looks like 2D, which is sometimes it's helpful to have that like reminder of like changing down the opacity, be like, no, this is legitimately 3D. And speaking of, just general dynamic Gaussian splatting, there was also a very cool demo as part of the exhibition hall from a company called Gracia AI. And just like, 4DV or Infinite Studios rather, they are showing a bunch of demos in VR for people to like walk around and explore Gaussian splatting. And it's very cool because you can still see like you get like a pretty nice like sense of presence for going into these demos, and you don't get nauseous or feel like any of this either, because the frame rates are already like well past real time. And so they had the demos available there at Siggraph, but they also have made the demos available for free through their website too. So if you have a Quest 3, a 3S, or a Pico Ultra 4, and you want to run it standalone without any other like device, they actually already support that too. So you can just go ahead straight to there, which is pretty mind blowing that this is running standalone on these devices. But if you have a any other headsets, you could just simply use like a workstation or computer, as long as it's PCVR, and you can experience the demos that way too.
I think it's going back to, again, expectations people have. They just assume that, like, a standalone headset should be able to run that, but that's really a crazy, amazing feat right there.
Yeah, exactly. And so it's been really exciting to like actually see the rate of like research get moved out into, the more tangible like world of product, and let people just start to explore. Some of the demos that they have are like they have like a cooking demo where you could watch a chef like make some food. That they have like a demo of like a doctor examining a patient. So you can imagine some of like the healthcare based applications just for like VR, but also like on a more practical, setting as well, where if you have a patient that would be better examined by someone who is not geographically located in the same place, you could imagine this technology helping medical professionals essentially examine patients from across the world. So that was also a very cool demo. One other one that I really liked in the exhibit hall or in, I guess, there are exhibits, was that they had a group of people showing another dynamic Gaussian splatting demo, but this one was actually live, where they had a small little array of 5 1K resolution cameras just in a small little arc, and basically you would just stand at the epicenter of them, and they were doing live dynamic Gaussian splatting reconstruction. So if you like wave on front of the camera, you'd see yourself on the screen waving too, but in 3D, and or at least about like 180-degree reconstruction of yourself. And that's very cool too, because if you imagine like saying to someone like, okay, I'm going to take a video of you, like a normal 2D video, and then I'll like show it on the screen right over here, people probably won't care at all or feel like what you're showing is important. But like I think it's still really novel to be able to say like we're going to be doing very rapid 3D dynamic reconstruction, and letting people interact with it and see this. So it was very cool for me to kind of step in there and just see where the pace of this technology is right now. And this was just from 5 cameras as well.
That's crazy, because that's the challenge, is like the 4D Gaussian stuff needs some pretty complex hardware and complex setup. So it's exciting to see companies working on fixing that challenge.
Yeah, and so it's exciting because to go back as well to the Infinite Studio demo, the CEO Jiaming said that they're looking at how can they create hardware that just natively creating dynamic 3D content for consumers. So it's just like I think that we hopefully are going to continue to see some evolving camera design in the not terribly far future, and ones that are more geared to shoot native 3D. We're seeing a lot of companies like XGrids, for instance, pioneering these static representations of the world. And so it's crazy to think that like maybe we're not super far off from like that 3D camcorder equivalent to creating dynamic moments in time.
Yeah, I mean, if you think back, like there's these like leaps of like technological leaps. You had digital imaging back in like the 80s, and it's like it was very much like we're talking about right now. It's challenging, you need a complex rig and all that. But then eventually, like a camcorder came in people's hands that like they could capture, and it's exciting. I don't think we've seen that uprise yet of like hardware products for this field yet, because I think everything's moving so quickly. It's like hard for a hardware company to even, companies like XGrids are like pioneers essentially at this point, because it's like landscape shifting so quickly that it's like, to put a stake down and like, we're going to build a product is like a pretty, like, it's a big thing. So it's really exciting to see the hardware side really come out.
Yeah, it's really cool to feel like, perhaps the cameras of the future may look a little bit different than the ones that we're used to, now. Some of the other things that I thought were really cool in the exhibit hall was there's actually a company that was 3D printing some of the different radiance field data sets. So here is the Lego bulldozer. Let's see if I can get you to. So this is like that classic data set one. And let's see if I can get it in focus. It's kind of like prioritizing my face. That didn't do it any better. So you can kind of see it here, where it's a full 3D print of the Lego bulldozer, and it was really fun to see. So that they had like the fox head from Nissan NGP. They had the Stanford bunny and some other of the more recognizable, data sets from radiance field reconstruction.
That's
So
cool.
yeah, it's really cool. It's a company called Cysta.ai, spelled CYSTA.ai. And hopefully I'm going to be chatting with their CEO in the next like week or so to talk about like when some of these things will be available for purchase, because I definitely want like a full life-size Lego bulldozer of this too. I feel like that would be like a fun little like gift for people in a I mean I just want one.
Yeah.
But
And I'm trying to post the links into the chat for people, but yeah, I think this is like an exciting. Everyone that's into Gaussian splatting is probably going to want a 3D print of one of their best splats, I feel like.
yeah, so that was like a really cool exhibit too. On some of the talks that were there, there was quite a few Gaussian splatting ones from the Kronos group, of which I got to participate in 2 of them. The first one was a town hall on standardization efforts, and again we got to see just like a really diverse set of industries that are utilizing or finding value using Gaussian splatting in some capacity. So some of the ones that we saw was like Esri and cesium, from the geospatial side, where basically Gaussian splatting is solving like a pretty like major bottleneck in the world of reconstructing really thin structures and highly reflective objects out in the physical world. So it seems like there's a lot of interest from the geospatial world into really leveraging Gaussian splatting's capabilities, both in geospatial and architecture, engineering, and construction. Some of the other places that we saw it too being talked about was actually in the journalism side of things. So AJ Shavar from the New York Times, spoke a bit about how their R&D department have been using and experimenting with Gaussian splatting, and he hinted a little bit as to perhaps sooner than later we'll see a full story be released with Gaussian splatting. So I definitely have my eyes looking out for that.
I mean, that's like just going back to the live Gaussian splatting demo you were talking about earlier. Those two together, I mean, like the journalism side, getting to be able to do live splats, that just changes like how people can consume news. They can go to these places rather than just seeing 2D photos of them.
Yeah, no, I completely agree. I'm really looking forward to that, like journalism use case of just really translating what it's like to be somewhere, especially in context of telling a story. Some of the other applications that we saw was like Meta spoke a bit about both Hyperscape, which is their VR equivalent of like Gracia, as well as talking a little bit about like the Kodak avatars as well, which are essentially really lifelike digital personas of people. So kind of like if you can imagine me talking to you right now, but no longer in 2D. So that was also very cool to see this like use of the technology. And then we also heard from NVIDIA as well, again about like NUREC and its capabilities within autonomous vehicle simulation and just general robotics applications. And we also saw a little bit about like the generative world too, and the existing framework. So World Labs presented their 3JS renderer Spark, which essentially is a really clean Gaussian splatting 3JS renderer, and it's nice to see like that tooling getting a lot of like support and interest.
Yeah, I mean, like I said again, it's not the sexiest part, but that's what ends up leading to consumers having products or that are utilizing this technology in their hands. So it's always exciting.
Yeah, and the second talk from the Kronos group kind of was more focused on GLTF extensions, where they're actually they're proposing 2 different ones. So there's KHR Gaussian splatting and there's KHR Gaussian splatting compression through SPZ. And so we kind of had a bit of a discussion about like where those extensions are currently, and there's just like an open call for contributions and like feedback now to start looking at the standards in terms of like, because there are so many industries that are finding value in this technology simultaneously, it's going to be really important to build a strong foundation for standardization that really caters to these different use cases. And so yeah, if anyone who is watching this has a use case, I would encourage them to also check out that GLTF extension.
Again, it's maturing. It's showing that the technology is maturing. When you only need standardization if there's usage. So it's always a good thing to be talking about in terms of how live is this technology and how relevant is this technology.
Yeah, exactly. And it's been really encouraging to see the level of interest across industries where it doesn't feel like this is a technology that will just impact just construction, or just be like really niche. I've continued to see just like a lot broader industry application of extending imaging into just a very lifelike 3D capacity for their work. So I was able to talk to people who work in the VFX industry, people who work in more like anthropology or archaeology applications, e-commerce, real estate, hospitality. These are all various people that I was able to interact with last week that have, in a lot of ways, expressed a lot of direct interest in, moving their business to cater more towards this technology. And so it's just been like really exciting for me to see this like increased adoption and excitement around really translating the world into lifelike 3D, so that we as like the end consumers can get even like closer to like moments in time, or you have better expectations be set when we go to purchase something, or whatever that application is.
It definitely sounds like to sum up, or what we're talking about, recapping, radiance fields at Siggraph, sounds like it's well alive and very much relevant into very many different industries. Tell us, what's your walk away from this? What did you leave Siggraph with, motivated or just learned from, that helped you get a new perspective maybe?
Yeah, I think it's just that I've been continuing to have to revise my expectations about like where this technology is going to be used and adopted. And the way that I've been revising it is just expanding my thoughts on it, where I've continued to have more and more conversations with people across very varied industries that have nothing to do with one another, that are still finding explicit uses for this technology. And that there's still a couple of things that I think need to be ironed out to make it into like a fully commercially viable and productized technology. But I feel very motivated that this technology is really making a difference and is working for people out in the field. So for me, I left it feeling like there's a lot more uses for lifelike 3D in its current form than I went into it believing. I already thought that it was going to do a lot, but I've just continued to see evidence of more industries finding value in this.
Awesome. So we'll give people a chance. If you have any questions, go ahead and put them in the chat, and then we can try and get them answered. And then we'll give people a second to do that while we talk about what would you say your most memorable, and it doesn't have to be radiance field, just your most memorable experience from Siggraph was this last week?
It's a good question. I think that like for me, seeing the tangible demos of the technology was just pretty exciting to just like get immersed into, whether that's in like VR or just like having it still on like a 2D screen in front of you. I think for me that's always really exciting, just to like see more and more new content that's being created. I really like the Myers demos, just to get because I can really see where this infrastructure will be critical, and like how they could really use the technology for a lot of different verticals to serve a lot of them. So those were really cool. There's one other one that I don't think I can like talk about yet, but was very cool. And I think that one will pop up within like a month or so on the internet.
That's exciting. We did get one question, which was, what was the name of the live dynamic 180-degree Gaussian splat demo? Maybe you can tell.
I think it was called Live GS. from what I think it's this one. Hold on. Live free viewpoint video via high performance Gaussian splatting for mobile devices. I think that was the name of it.
Yes. All right. Awesome. Do you want to just kind of talk a little bit more about like what you thought of that demo?
Yeah, I just thought it was awesome. Where the cameras like were not really, they weren't high-end mirrorless cameras, and they weren't like these machine learning cameras either. These were generally inexpensive cameras that were able just to be like kind of set up in a row, and we're able just to do pretty much near instant dynamic reconstruction of this. I was pretty amazed by it, and it was just running from like a laptop as well, I believe.
Wow, real-time GS from a laptop. That's crazy.
Yeah, it's wild the amount of like progress that's like both in the research world, and hopefully soon will be making its way out to just all of us in the real world.
Yeah. Well, let's I guess we don't have any other questions. If you have any other questions, just shoot them out, and then we'll get them answered some other way. But let's do like a final takeaway, I guess. What do you want to leave people with?
Yeah, it sounds like to me, from my perspective, that Gaussian splatting is just continuing to make its way out into the real world, and that a lot of companies that have been building in stealth for the last year or so are starting to make their way out for people. So I would not be surprised if we see a lot of really cool applications for lifelike 3D by the end of this year. And it's exciting to see NVIDIA as well start to put a bit more direct weight behind this technology and bringing it into its core ecosystem.
Yeah, it's going to be an exciting. The last half of this year is going to be really exciting for radiance fields. I think there's going to be a lot of new solutions, and I know as talking to people, there's a lot of people that are working on solutions. So it's a really active area. We did get one more question. Were there any hints of any future capture technologies beyond Gaussian splatting?
Being non-Gaussian splatting?
Beyond Gaussian splatting.
There may have been, but I may have just not had the bandwidth to see them. It's from just my own, I guess, schedule. All I saw was like Gaussian splatting.
Yeah, right now it seems like it solves a lot of the problems, and while it still has limitations compared to NERFs, it's the better or the easier deployable, I guess, of the two. So I think it's more popular, I'd say. Would you agree?
Yeah. I mean, there's a lot of like nice upfront advantages to Gaussian splatting that I think have like contributed to its very quick rise and deployment. It's really only been like less than 2.5 years since the original publishing of the paper, and we already have like both hardware and software that is like somewhat dedicated to creating this medium. So yeah, there's a lot of really nice upfront advantages to it. I mean, we'll see. Gaussian splatting is not the only radiance field representation that exists, and it's a very active area of research. So I mean, we'll see if any of the previously published ones are able to also create a lot of use cases for people, or if a completely novel one emerges, or if it is just Gaussian splatting. We'll see. But at the end of the day, the floor of this technology is really lifelike 3D that renders in real time across a majority of devices.
And it's amazing. So yeah, thanks everybody for joining us. I think we've covered the gist of it, which is that radiance fields are well and alive and are hot. And so we're here at ARC. We're trying to highlight anything we can of people that are utilizing this technology. So if you haven't already subscribed, please subscribe. Or you can follow us on our social channels as well. And so we'll talk to you again. Thanks for joining us, Michael. And
Thanks.
All right, bye everybody.
Thanks so much. Bye.